Hello. Today we've pre-calc lesson 53. We are going to be taking a slight break from doing some trig functions, which is nice. We're still going to be using radians, but a nice little break. We're going to do review of unit multipliers and angular velocity, something new. So unit multipliers, we all should know, contains units, has a value of 1, consider reciprocals as well, used to make unit conversions, blah, 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 blah. All of this is what we're going to do to convert to different units. Okay, so let's do a quick review example. 40 miles per hour to meters per second, excuse me. So we have 40 miles per 1 hour. Let's convert to seconds first. So we know that there are, in 1 hour, there's 60 minutes. In 1 minute, there's 60 seconds. Our hours cancel, our minutes cancel. Then let's do miles to meters. We know that in 1 mile, there's 5,280 feet. And we know that in 1 foot, there's 12 inches. I might run out of room. I'll go down here. And so let's cancel miles here. Let's cancel feet. We know that in 1 inch, there's 2.54 centimeters, and there are 100 centimeters in 1 meter. So we multiply it all out. Excuse me, on top we'll have 40 times 5,280 times 12, all over 1 times 60 times 60 times 1 times 1. Times 100, and this is times 2.54 meters per second. Often your book will ask you to just leave it like this. I will give you specific instructions that will say multiply it out or don't multiply it out. This is the non-multiplied out. Okay. Now let's talk about linear velocity. You should have talked about this some in physics, I believe. So linear velocity has both magnitude and direction, okay? Whereas angular velocity, its direction can be counterclockwise or clockwise, and it measures the rate of rotation of an object. So we're going to be talking about, for example, if you had a wheel, how something would be rotating on the wheel. The units we have are going to be degrees per second, radians per second, revolutions per second, or you could do minutes. I'm going to show you more in depth what this looks like as we do an example. And if we have 2 points on a wheel, something rotating, okay, the linear velocities are different, but the angular velocities are the same. If 2 things are on the same wheel, then they are rotating at the same rate. Okay. Now, we have B is our linear velocity. R is our radius, and omega, it's not a W, it's omega, is our angular velocity. In this formula that we use, V equals R omega. Okay, this is to find our linear and angular velocity. The units are going to be in radians per unit time. Okay, so that is for angular velocity. Omega is measured in radians per unit time. Okay, now if angular velocity is given in revolutions per minute or degrees per minute, the revolutions or degrees must be converted to radians in order to calculate linear velocity. Okay, and I will show you how to do that with this example. So the wheel of a wagon has radius, so R, of 14 inches, and is revolving at 40 revolutions per minute. That's our omega. So omega is 40 revolutions per minute. Okay, now remember, we need it in radians per unit time. So we're going to convert this. Okay, there are 2 pi radians per 1 revolution. Think of a revolution as going all the way around a circle. So this really gives me 80 pi radians per minute. You have to convert your omega. How fast is the wagon moving? So we know that's the linear velocity because the wagon's going linearly. in miles per hour. So V equals R, 14 inches, times omega, 80 pi radians per minute. Now we have to convert, we want it in miles per hour. Okay, so let's first convert from inches to miles. So we know that there are 12 inches in 1 foot, cancels our inches, and in 1 mile there are 5,280 feet. Now we're in miles. Now let's do time. We know that there are 60 minutes in 1 hour, canceling our minutes. We don't have to cancel our radians. Okay, so now we will have 14 times 80 pi times 60 all over 12 times 5,280. This is in miles per hour. Now I'm going to leave my answer like this just because that's how your book leaves it right now. But again, I will tell you if I want you to multiply it out or not multiply it out. Okay? All right, let's do this next example. An automobile whose wheels are 30 inches in diameter, so that tells me my radius is 15 inches, is traveling at 40 miles per hour. That's my linear velocity, 40 miles per hour. What is the angular velocity? That's what we're looking for, of the wheels in revolutions per second. Okay, so in my equation, I have V equals R omega, so 40 miles per hour equals 15 inches times omega. So omega is 40 miles per hour over 15 inches, which I'm going to write as 40 over 15 inches hours. Okay, because I have to now convert this. Okay, so we want it in revolutions per minute. So what I'm first going to do is I'm going to get rid of my miles and my inches. Okay, so I know that there are in 1 mile 5,280 feet. My miles cancel. And then in 1 foot there are 12 inches. My feet cancel and my inches cancel. Okay, now I'm also going to convert to seconds from hours. So I know that in 1 hour we have 60 minutes, and in 1 minute, so my hours cancel, my minutes cancel, there are 60 seconds. So right now, omega, I have 40 times 5,280 times 12 all over 15 times 60 times 60, and right now I have it in radians per seconds. Now I need to convert. I know that there are 2 pi radians in 1 revolution because I want it in revolutions per second. So I end with 40 times 5,280 times 12 all over 15 times 60 times 60 times 2 pi revolutions per second. Okay, again, your book leaves it non-multiplied out like this. I personally like to multiply it out because I think this looks really silly, but I wanted to show you what the book has you do. Okay, again, I will give you very clear directions what I want you to do on a quiz or on a test. Okay, so new formula, V equals R omega, that you need to memorize. We will be using it from here on out. That is all for our lesson today. See you tomorrow.